everyone, it's Miss Hill, and I have the honor today of bringing you some notes and brilliance about exponents. So we are going to briefly, 10 minutes or less, talk through three crucial properties about exponents, and those are multiplication, division, and the zero property. We're going to take a walk through all of those. I'm also going to take a moment and just back up the train and talk about what an exponent is really quickly and some key definitions, right? Like your math teachers have told you forever, math is another language. And if you can speak the language, you have a whole world that opens up to you. So step one is understanding what are the pieces of an exponent. So within an exponent, I've got powers and bases, and then I have the little exponent. So we're going to draw a little example, and I'm going to use 3 as what I'm going to call my base, and with a different color because I like to be fancy. I'm going to put a 4 up top, and in pink, I'm going to identify what all of these are called. So this 3 right here, that guy is called the base. It really is all about the base. Okay, sorry, I'll stop. The 4 right up top up here, that's my exponent. All that number is telling me is how many bases I've got. So in this example, I have 4 3s that I'm multiplying together. That's what that entire annotation is showing you. Now, if I wanted to name this entire thing, the 3 with the 4, the whole thing, then I'm going to call that a power. Okay, so that breaks down a little bit of the vocab. I'm going to read that as 3 to the 4th power. So again, we've got the power, which is the whole expression, and I'm going to just jot this down for you. Great idea to copy it yourself. The power is the entire expression with 2 parts, and those 2 parts are the base and the exponent. The base itself, so of course I gotta underline that. The base itself is the repeated factor. That's fancy math language for saying the number that I'm going to keep repeatedly multiplying, right? And then the last word that we're using here is exponent. And the exponent is basically just telling me the number of times the factor, in this case the 3, is repeated. So math can be broken down into much simpler language, and that's what I'm hoping that conversation has done for you. So there's some key pieces that you've got to be able to do when it comes to exponents. The first is to do what we call expanded form. So to take an exponent and write it out in expanded form. Basically, like taking it from shorthand to longhand, right? I'm writing it out in a longer version to show what's actually happening. In math, we love to simplify things. We love to write them in shorter ways, but one skill set to prove and verify your answer is to be able to show something in an expanded form, because then you're showing what's happening. So let's do a couple of examples of expanded form. So I'm going to call this section expanded form. And I'm going to use the same example we used up top. Why reinvent the wheel, right? Okay, so if I've got 3 to the 4th power, that 4 is telling me I've got 4 of these 3's that I'm repeatedly multiplying by themselves. So what that would look like is 3 times 3 times 3 times 3. So I've got 1, 2, 3, 4 of them. Since I'm in Math 8, I am using the multiplication symbol of a circle, not an X, because we want to get away from the use of a variable. So expanded form wouldn't be necessarily solving that. I could do 3 times 3. That's going to give me 9. If I multiply that whole thing out, right, I'm going to get a much larger number. I'm going to end up with 9 times 9. And so 9 times 9 is going to give me 81. But expanded form is just having me write all of those 3's out. Now, here's something that you might see that kind of takes it up a notch. So let's say that I had 3 squared, 3 to the 2nd power, right? I've got 2 of those 3's. But then let's say that that whole thing was being raised up to the 4th power. So a power to a power. In that case, it's telling me that I have 4 sets of these 3 squareds. So I have 3 squared. I'm going to use my parentheses to keep the 3 and the squared together. We like to be specific in math, right? So that 4 up top was just telling me you've got 4 of these 3 squareds. But if I need to expand that guy way out, each one of these parentheses holds a 3 squared, meaning I have 2 3's sitting in there, right? So I've got a 3 times 3 in there, times a 3 times 3 there, times a 3 times 3 there, and then a last one. So I had 4 sets of those, which means I have 1, 2, 3, 4, 5, 6, 7, 8 of them. So if I'm raising a power to a power, I'm going to multiply those exponents. 2 times 4, that would be the fast way to get there. But if I'm showing expanded form, which is what we just worked through, then I actually want to get it written all the way out as long as I possibly can. Okay, so that's just your background. Now what I'm going to do really quickly is jump into how do I multiply powers, how do I divide them, and then what happens if I get an answer with an exponent of 0. So we're going to tackle those 3 things pretty quickly here. All right, so let's talk about what happens if I need to multiply. We're going to call this multiplying powers. Now, the first thing that I'm going to make sure that you're clear about is that in Math 8, you are going to be getting examples where your bases are always the same. Here's what I mean. Let's say that in this example, I have 5 squared, and I'm multiplying that by 5 to the 6th power. Notice that my base is 5 in both of those terms, right? Terms are separated by multiplication in this example. So I've got 5 squared, and then I have 5 to the 6th. Now, if I wrote that out in expanded form, this 5 squared means I have 5 times 5, got 2 of them. And then 5 to the 6th power says I have 6 more of those 5's that I'm multiplying. So I'm going to multiply 6 more. 1, 2, 3, 4, 5, 6. And I'm just using expanded form to show you what the rule is for multiplying powers. So how many do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8 of them. So my answer here, and we're going to leave our answers in with the exponent. We don't need to actually get to a standard answer. We're going to leave it as 5 to the 8th. If I take a look at my answer and all the way back to the beginning, what's the relationship between 2 and 6 and 8? Well, in this example, I have a base of 5. If I take my exponent of 2 and I add 6 more, what do I get? I get 5 to the 8th, which is the same answer we got when we took the expanded form route. So multiplying powers, I'm going to give you the rule here. When multiplying with the same bases, that's key. All you need to do is add the exponents. Now I'm sure that you could think about what would happen if we were doing the opposite. So in this example, I'm multiplying bases. So I added my exponent. Multiplication and addition are linked. And so think about what would happen the opposite way. What if I'm dividing like powers? What would be the opposite process for me to follow? So think about that question. And I'm actually going to turn my page here. And let's talk about that. Let's talk about if I am dividing powers. So let's go back and use that same setup, right? So I've got a base of 5, and I'm going to say my exponent is 6, and I'm dividing 5 squared this time. Now if I were to write that out in expanded form, I'm going to write 5 times 5 times 5 times 5 times 5, 6 of them, right? And I'm dividing that by 5 times 5, 2 of them, right? 5 to the 6th means I have 6 of them. Dividing it by 5 squared means I have 2 of them down here. Now, because we are mathematicians and we simplify before we do any kind of dividing, I'm gonna simplify what I can. Well, 5 divided by 5, that's gonna cancel. It's gonna give me 1. I don't need to write that. 5 divided by 5 is gonna cancel. So I've got nothing left in the denominator. What I'm left with in the numerator is 4 of these 5s. Just 5 to the 4th power, simplified. So look at the relationship there, the relationship between 6 and 2 and 4. So this time I didn't add the 6 and the 2. What I actually did was I subtracted the 6 and the 2. So that is where I get 5 to the 4th power. So the rule that we want to write down is when dividing like bases, again, key, all you need to do is subtract the exponents. Again, in Math 8, it is perfectly acceptable to leave your answer with the exponent. You don't need to multiply that out and get a final answer. Okay. I'm going to show you one really quick thing, and I'm going to make this video less than 15 minutes, I promise. And the last thing I'm going to talk to you about is called zero power. Sorry, zero property. So here's what happens sometimes, especially you'll see it a lot of times when you are doing division of powers. You'll see it a lot of times when you're doing multiplying of powers that might have a positive and a negative that are opposites of one another. But sometimes you're going to get an answer that ends up with a power of 0. So let me just walk you through an example and just tell you what always happens when your exponent becomes 0. So let's stick with our base of 5, because why not, right? And let's say my exponent this time is a 4. And I'm dividing it by 5 to the 4th power. That's on purpose. So what does that mean? That means that I have 4 of these 5s up top in my numerator. It also means I'm dividing by the same number in the denominator. Now, if you are looking for patterns like my brain does, you're noticing something here. Those are all going to cross off, right? Those are all going to simplify with one another. 5 divided by 5 is 1. 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 Anything divided by itself is always 1. So the rule with zero powers, right? If I had just used my division property and just subtracted those exponents, the answer I would have gotten was 5 to the 0 power. So the rule here is when the exponent is equal to 0, and I'm going to write the word out so that you know that it's not the letter O. When the exponent is equal to 0, the entire power, meaning the base and the exponent, is equal to 1. And we just saw that with the division example. I really hope these notes have been helpful. Make sure you're keeping a spiral with some math notes. We'll be providing these for you every week, and your teacher is going to take it from here. So have a really great week, everybody. Bye.